My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Operation Research as prescribed by Osmania University, Palamuru University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 5 first important short question is Queuing theory. Queuing theory is the study of waiting lines or queues. It helps us understand how customers or items wait for service and how to reduce their waiting time. Example, think of a ticket counter at a railway station. People come, arrive, wait in line, and then are served issued tickets. Queuing theory helps decide how many counters are needed. How long will people wait? Can we reduce the waiting time? In operations research, queuing theory is used to analyze and design systems where waiting happens, like banks, hospitals, restaurants, or call centers. It uses formulas based on arrival rate, how fast people come, service rate, how fast service is done, and queue discipline, like first come first served. Why it's useful? It improves customer satisfaction, reduces time and cost, and helps in better resource planning. Easy tip to remember. Queue means wait plan to reduce the wait. Next important short question is 2. Probabilistic queuing model. A probabilistic queuing model is a type of queuing model where the arrival and service times are uncertain and based on probability. Example, in a hospital emergency room, we don't know exactly when patients will arrive or how long each treatment will take. Some may take 5 minutes, others 30 minutes. This random behavior is studied using probability. In this model, arrival rate, lambda follows a Poisson distribution, random arrivals over time. Service time, mu follows an exponential distribution, random service duration. System analyze. Like MM1 model, one server, Poisson arrival, exponential service. This model helps management answer how many customers are in line. How long does each one wait? How to reduce waiting time or increase efficiency? Easy tip to remember. When time is random, go with probability to plan the queue smartly. It's very useful for unpredictable environments like call centers, clinics, etc. Next important short question is 3. What is game theory? Game theory is a decision-making tool used when two or more players, individuals or businesses, compete or cooperate to get the best outcome. Example, two companies, A and B, launch new smartphones. Each can set a high or low price. The profit of each company depends not only on their decision, but also on what the other company does. This is a game in game theory. In game theory, players is equal to decision makers. Strategies is equal to different choices available. Payoffs is equal to results, like profit or loss. There are different types. Competitive games, like cricket match, one wins, one loses. Cooperative games, players work together for mutual benefit. Why is it useful? It helps in business planning, war strategies, pricing decisions, politics, etc. Easy tip to remember. Game theory is equal to smart thinking in a competitive world. It teaches how to think ahead and choose the best move, just like in chess. Next important short question is 4. What is a two-person zero-sum game? A two-person zero-sum game is a special type of game in game theory where there are only two players. One player's gain is exactly equal to the other's loss. The total profit or loss in the game is always zero. Example. Imagine a betting game between player A and player B. If A wins 100 rupees, then B loses 100 rupees. Here, A's gain plus 100 plus B's loss, 100 is equal to 0. That's why it's called a zero-sum game. Why it matters? This model helps in decision-making where competition is involved, like in military strategy, sports, or pricing between two firms. Important points. Focus is on opposing interests. No win-win situation. If one wins, the other loses. Solved using strategies like minimax or maximum. Easy tip to remember. Two players, one winner, what one gets, the other gives up. Next important short question is 5. What is saddle point? In game theory, a saddle point is a position in the payoff table where the minimum value in its row chosen by the row player, the maximum value in its column chosen by the column player. It represents the best strategy for both players, where neither player wants to change their decision. Example. Consider the following payoff matrix. Player A is row player, player B is column player. B1 B2. A 1 3 2. A 2 4 5. In a 2 row, 5 is the minimum. In B2 column, 5 is the maximum. So, 5 is a saddle point. Why is it important? If a saddle point exists, the game has a clear solution. Both players can choose their strategies confidently. Easy trick to remember. Saddle is equal to safe spot. It's the stable point where both players feel safe sticking to their choices. Next unit we. Long questions. First important long question is 1. Discuss in detail various single-channel queuing models. Various single-channel queuing models. In queuing theory, a single-channel queuing model refers to a system where there is only one service point, one counter, one doctor, one machine, etc., and customers arrive one by one to get service. These models are useful in everyday situations like a single billing counter at a supermarket, a ticket window at a railway station, a doctor's clinic with one doctor. Let's explore the main types of single-channel models. 1. Model 1, MM1 FCFS. MM1 means Poisson arrivals, random, exponential service time, and one server. Infinite population. FCFS, first come, first served. Example, a single ATM machine where people come randomly and each takes a different time. Key formulas. Lambda is equal to arrival rate. Mu is equal to service rate. Utilization factor, rho is equal to lambda mu, should be 1 for stability. LQ, average. People in queue is equal to rho superscript 2, 1 rho. WQ, average. Waiting time in queue is equal to LQ lambda. 2. Model 2, MM1 NFCFS. Same as above, but population size is finite, n. Used when only a limited number of customers can queue. Example, workshop with only 5 machines waiting for one mechanic. 3. Model 3, MM10. Similar to Model 1 but service in random order, 0 is equal to service in random order. Less common in real life. 4. Deterministic single-channel model. Arrival and service times are fixed, not random. Useful in systems like automated machines working on a schedule. Summary. Model queue-type service pattern common use. MM1 random exponential most real-life queues. Deterministic fixed automated systems. Easy to remember tip. Single channel is equal to one counter. Many customers. Just think of any place where people wait in line for one service point. Next important long question is to explain the theory of dominance in solving a given game. Theory of dominance in game theory. In game theory, the dominance rule is a very helpful method to simplify a game table by eliminating unnecessary strategies, rows or columns. What is dominance? A strategy is said to be dominated if there is another better strategy that gives equal or better results in all situations. For player A, row player, if row 1 is better than row 2 in all columns, then row 2 is dominated and can be deleted. For player B, column player, if column 1 is worse than column 3 in all rows, then column 1 can be eliminated. Why use dominance? It helps to reduce the size of the matrix and makes solving the game easier. Steps to apply dominance rule. 1. Check rows. Compare all rows. Strategies of player A. If any row is always better than another, remove the dominated row. 2. Check columns. Do the same for columns. Strategies of player B. Remove any dominated column. 3. Repeat. Keep applying the rule until no more rows or columns can be deleted. 4. Solve the reduced game using saddle point, graphical method, or algebra. Example. Let's take a simple 3 times 3 payoff matrix for player A. B1 B2 B3. A 1 to 3 4. A 2 1 to 3. A 3 5 1 0. Now compare a 1 and a 2. A 1 is better than a 2 in all columns. A 2 is dominated. Remove a 2. Now compare a 1 and a 3. No full dominance. Keep both. Compare columns. Suppose B2 is worse than B1 in all rows. Remove B2. Now, you have a smaller matrix to solve. Easy to remember trick. Better beats the rest, cut the worst. Always keep strategies that give higher, for A, or lower, for B, payoffs. Conclusion. The dominance rule makes solving games simpler and quicker by eliminating weak strategies without affecting the final answer. Next important long question is 3. Explain the graphical method used to solve mx2 and 2xn games with example. Graphical method to solve m times 2 and 2 times n games. What is the graphical method in game theory? The graphical method is used to solve two-person zero-sum games when one player, say A, has 2 strategies. The other player, say B, has more than 2 strategies, m times 2 or 2 times n matrix. This method helps to find the optimal mixed strategies and value of the game using graphs. When to use? If A has 2 strategies and B has 3 or more, use graphical method. Also valid when B has 2 strategies and A has more than 2. Steps to solve 2 times n case. Assume player A has 2 strategies, a 1 and a 2. Player B has n strategies, B1, B2, Bn. Payoff matrix is from A's point of view. Let A choose a 1 with probability P and a 2 with probability 1 P. 1. Find expected payoff for each strategy of B. EB1 is P times a 1 plus 1 P times a 2. Do this for all B strategies, B1, B2, Bn. 2. Plot all E values on graph paper. Y-axis is equal to payoff, x-axis is equal to P from 0 to 1. 3. Draw n lines, 1 for each strategy of B. 4. The lower envelope, bottommost curve, shows the best response B can force. 5. The highest point on this lower envelope gives O optimal P for A. O value of the game. Example. B1 B2 B3. A 1 to 3 1. A 2 4 1 5. Let A play a 1 with probability P. Then expected payoff versus B1 is equal to 2P plus 4, 1 P is equal to 4 to P. Versus B2 is equal to 3P plus 1, 1 P is equal to 1 plus 2P. Versus B3 is equal to 1P plus 5, 1 P is equal to 5, 4P. Plot these three lines, find the lowest point that touches the top, and read P and gain value. Easy to remember. Graph helps to crack, just draw and track. Use lines, find the lowest upper line, and you get the best strategy. Conclusion. Graphical method is a visual and simple tool to solve 2 times n or m times 2 games. It helps find the best mix of strategies without using complex algebra. Next important long question is 4. Explain the process of simulation with its applications in different management problems. Simulation, process and applications in management. What is simulation? Simulation is a method used to imitate or copy a real-life situation using a computer or a model to study how a system behaves over time. It is very helpful when the system is too complex or risky to experiment with in the real world. Simple meaning, simulation means testing something in a fake or safe environment before doing it in real life. Process of simulation, easy 5-step process. 1. Define the problem. Clearly understand what needs to be studied. Example, simulate how many customers are served in a bank queue per hour. 2. Build a model. Create a model, mathematical or logical, that represents the real-world process. Example, model of customer arrival and service time. 3. Collect input data. Gather necessary data, arrival rates, service times, costs, etc. 4. Run the simulation. Use a computer program to run the model multiple times with different inputs. 5. Analyze the results. Study the output and draw conclusions. Example, how many staff should be hired to reduce waiting time? Applications of simulation in management. Simulation is used in many areas of management to reduce cost, save time, and improve decision-making. 1. Operations management. Factory layout design. Assembly line balancing. Inventory control. 2. Queuing problems. Simulation of bank queues, hospital emergency lines, or customer service centers. 3. Finance. Risk analysis in investments. Forecasting cash flows and profits. 4. Marketing. Testing customer response to advertisements. Simulating market demand. 5. Human resource management. Staff scheduling and shift planning. Easy example. A hospital wants to reduce waiting time in its emergency ward. Using simulation, they model patient arrival times, random. Doctor availability. Service time for treatment. After running the simulation, they find that hiring one extra nurse reduces waiting time by 40%, much better than guessing. Conclusion. Simulation is like a virtual lab for managers. It helps them experiment, test, and predict outcomes before making real-world decisions. Tip to remember, simulate before you operate. Next important long question is 5. A warehouse has only one loading dock manned by a 3-person crew. Trucks arrive at the loading dock at an average rate of 4 trucks per hour and the arrival rate is Poisson distributed. The loading of a truck takes 10 minutes on an average and can be assumed to be exponentially distributed. The operating cost of a truck is 20 rupees per hour and the members of the loading crew are paid 6 rupees each per hour. Would you advise the truck owner to add another crew of 3 persons? Queuing problem, warehouse loading dock. Question summary. 1 loading dock with 3-person crew. Truck arrival rate, lambda, is equal to 4 trucks r, Poisson. Service time per truck is equal to 10 minutes 6 trucks r, because 60 divided by 10 equals 6. Operating cost per truck waiting is equal to 20 rupees per hour. Cost per worker is equal to 6 rupees per hour times 3 workers is equal to 18 rupees per hour. Question: should we add one more crew, 18 rupees per hour extra, to reduce waiting cost? Step-by-step solution. Step 1. Identify system type. This is a single-channel queuing model, MM1. Poisson arrivals, lambda. Exponential service time, mu. One service point, crew of 3 is treated as one server. Step 2. Find key values. Arrival rate, lambda, is equal to 4 trucks r. Service rate, mu, is equal to 6 trucks r. Step 3. Calculate server utilization, rho. Rho is equal to lambda mu is equal to 4 6 is equal to 0.667. The system is 66.7% busy, which is acceptable. Step 4. Calculate average number of trucks in system L. Formula. L is equal to rho, 1 rho, is equal to 0.667, 10.667, is equal to 2 trucks, approx. So, 2 trucks, on average, are in the system, either waiting or being loaded. Step 5. Calculate cost. Waiting cost is equal to no of trucks in system times truck cost r is equal to 2 times 20 is equal to 40 rupees per hour. Crew cost, current, is equal to 18 rupees per hour. Total cost now is equal to 40 rupees, waiting, plus 18 rupees, crew, is equal to 58 rupees per hour. Step 6. If new crew is added, service rate will increase, maybe 12 trucks r. Utilization is equal to 4/12 is equal to 0.33. Average trucks in system is equal to 0.5. Waiting cost is equal to 0.5 times 20 is equal to 10 rupees per hour. Crew cost is equal to 18 rupees times 2 is equal to 36 rupees per hour. New total cost is equal to 10 rupees plus 36 rupees is equal to 46 rupees per hour. Final advice. Yes, adding one more crew is advisable because total cost reduces from 58 rupees per hour to 46 rupees per hour. Also improves customer service and truck turnaround time. Tip to remember, add resources if the asterisk total cost, waiting plus crew, reduces.